So to continue with lesson 7-8, where I was cut off here, there's a word problem and there's a couple more examples that I wanted to look at. So the word problem, we're given a sequence, but it's talking about the money that Ronald has in his savings account, and it earns interest each year. He does not make any withdrawals, so he doesn't take any money out or additional deposits, so he doesn't put any more money in. So the account balance at the beginning of each year is going to be the list here: $10,000, $10,300, $10,609, and $10,927.27. So we're going to use that sequence to write a recursive and explicit formula. Now, the recursive formula is going to come from the setup that we've been using. The explicit formula is going to be more of the algebraic sequence setup. So we're going to first, for the recursive formula, the first term is 10,000. So that's our a sub 1 in the formula. N has to be greater than or equal to 2, which is always our domain. And then we're trying to figure out whether this is a common difference or a common ratio. So we're going to subtract the first term from the second term. So 10,300 minus 10,000 gives me 300. Then if I take 10,609 minus 10,300, I get 309. So I already know that it's not a common difference. So to come up with the common ratio, I need to divide now. The second term divided by the first term, which is going to give me 1.03. Then if I do that again, the third term divided by the second term, it's also going to give me about 1.03. So each time we're going to get a common ratio. So it's going to be a common ratio for our setup. And that means that we use R times a sub n minus 1 as our setup. So we're going to do R, which is 1.03. We always start with a sub n. So a sub n equals R, which is 1.03, times a sub n minus 1. And that would be our formula. And that's the recursive formula. Now the explicit formula is going to use this setup if it's not a common difference, which is a sub n equals a sub 1 times the ratio, and then the n minus 1 is to the exponent's position. So we're going to do a sub n equals the first term, a sub 1, which is 10,000, times our ratio. We can put that in parentheses, and then the n minus 1 is the exponent. And that we hadn't actually gone over, but this is the explicit formula if it's not an arithmetic sequence and it's a geometric sequence. That's the explicit formula setup. So there's actually 3 setups that you need to know. There's the 2 different recursive formulas for the arithmetic sequence and the geometric sequence, and then there's there's actually 2 different explicit formulas, one for the arithmetic sequence, which we've done before in a couple chapters ago, and one for the explicit formula, which is here. Then the last example is we're going to write a recursive formula. So we're going to write a recursive formula for a sub n equals 4 times 3 to the n minus 1. So that's kind of what we just looked at. So we need to figure out what the first term is, which, if we look back, the first term is the first number listed, a sub 1, in this formula. So that's going to give us a sub 1 is 4. And then we need to figure out the recursive part of the formula. Well, 3 is going to be our common ratio. So using the recursive formula setup, it was a sub 1 equals r times a sub n minus 1. And n is greater than or equal to 2 always. So we have the a sub n equals r. We just need to plug in the r, which comes from this part of the formula. So it's 3. So we're going to write this as a sub n equals 3 times a to the n minus 1. And our domain is always the same. N is greater than or equal to 2. So these are the 3 parts that they want us to write. And then the last one, write an explicit formula. That is going to be using our arithmetic sequence setup. So it was a sub n equals a sub 1 plus n minus 1 times d. So we need to look at what they give us here. A sub 1 is given as negative 16, so we're going to plug that in. Plus n minus 1, we don't know, so we're going to leave that as n minus 1. And the d is going to be the negative 7. And we're going to simplify this. So that gives us, we're going to simplify by distributing. So we get negative 7n plus 7 plus negative 16. And we can simplify that to be a sub n equals negative 7n minus 9, or plus negative 9. And that concludes lesson 7-8.